Hello, everyone. I had an older sister who always wanted to be a teacher from probably the moment she was born. And from the time I could talk, we got to play any game I wanted as long as it was school. And as long as she got to be the teacher. I was never allowed to be the teacher. So she was 3 years older than me, and when I started school then, I was way ahead of all the other kids. I always excelled at school. Every subject was easy for me. Math, not a problem. Science, not a problem. English, foreign language, band, everything was very easy. I left secondary school and I enrolled in the university and majoring in civil engineering. I had no doubt I would be able to do it. I had my first quarter, took calculus, chemistry, English, all those subjects, straight A's again, no problem, very easy. My second quarter, I took a course, my very first quote-unquote engineering course, and it was called Engineering Graphics. And for the first time in my life, I had no idea what was going on. I was struggling. I had no idea how to solve the problems. I had no idea what the teacher was talking about. And what made it worse for me is that all of these friends of mine, they said this is the easiest class they've had all year. And I couldn't do it. And I nearly left engineering because of that. But I stuck with it and eventually, got a PhD in mechanical engineering. And I started looking into what had happened to me, and I partnered with some people, and I'm going to tell you about that later, but first I'm going to go through some things that we know about engineering that many of you who don't have an engineering background might not understand. And the first one is that a lack of diversity often means lower or a lack of creativity. So when engineers always work on teams. And what they found is that if you have a very homogeneous group, they all think alike, they all come up with the same ideas, and they don't understand, for example, that if you have young people designing things for old people, that they have different needs. Or if you have men designing for women, that their needs are different. So some of the more famous or infamous examples many of them are in the automotive industry, where they have airbags that are perfectly fine for your average male, but they can injure a woman or a child who's smaller. You have a tailgate on a minivan that the average woman can't pull down. A lot of things that happen, it's not that they're not creative, it's just that they're not as creative as they can be. So we really need to have diversity in order to have creative solutions. But this is the big problem. Engineering is very non-diverse. In the US and elsewhere around the world, about 10% of engineers are women. And for underrepresented minorities in the US, it's even less. So here we have this problem, right, where we need creative solutions. We have big problems in our societies today, and we don't have enough women who are in engineering. Now, one other thing is that engineering careers require high levels of 3D spatial ability. And so when I was struggling in my class as a first-year engineering student, my problem was really that I had poorly developed spatial skills, not that I couldn't do the engineering. So if you think about engineers, they have to think about how things fit together, how things work together, how the ducts and the pipes and the wires are going through buildings. It's a very spatially demanding field. And this is a test that we give the students to determine their level of spatial ability. And it's called a test of mental rotation. And you have an object on the top line. It's rotated in space as you move from left to right. There's a second object on the second line, and you have to say, okay, if I rotate this by the exact same amount, what would it look like? For those of you who don't know the answer to this one is D. The next problem is that the 3D spatial skills of women lag significantly behind those of men, right? So this is data that I've gathered over the past 15 years, and you can see that the women are always behind the men in terms of their 3D spatial skills. And this is across the world. So it's not just me. I've worked with people in Germany, Poland, Japan, Ireland, and I find weak spatial skills among the women almost always. In fact, on this test that we give them, about 30% of the women fail that test when they start their engineering coursework, but only about 10% of the men fail that test. So women are 3 times more likely to have problems with their 3D spatial skills when compared to men. But the one thing that I want to say is nobody really knows why women have weaker spatial skills. And it doesn't really matter why they have weaker spatial skills, because spatial skills can be learned. A lot of people think that this is a fixed quantity. You either started out, you can either read a map or you can't read a map. And you can never learn how to read a map if you didn't learn, if you weren't born with it. But I want to say, from my own experience, as a learner as well as a teacher, spatial skills definitely can be learned. So what did we do? Well, about 20 years ago, we developed a course aimed at first-year engineering students to help them learn to visualize. And I got into this, obviously, because I had had my own troubles with spatial skills. And I was eventually teaching engineering graphics, and I found that there was always kind of this core group of students who struggled with their spatial skills or struggled with that particular course, and predominantly it was women. So we started a course. The course has been offered many times. It's actually not, I tell people all the time, it's not really rocket science. It takes about 15 or 20 hours of instruction, so it's not overly difficult. But what did we find then? Well, the first thing is that we improve people's spatial skills, which is good. If you're going to develop a course designed to help you improve your spatial skills, you actually want to have them improve their spatial skills at the end of the day. This shows 6 years worth of data. I could show you 20 years worth of data. It's about the same. Students in the class start about at 50% on this test, and they end up at about 80%. And what's interesting is that the 80%, that's about where the first-year engineering students as a whole start out. So these people are starting out way behind, and they end up at about where everybody else is. Great. We improved their spatial skills. What else? Well, we improved also their grades in a lot of their STEM courses. So here you can see they're earning about a half of a letter grade better by going through the spatial skills training. And not just in their engineering graphics course, but also in their calculus course, chemistry a little bit, physics, and computer science. So all of these fields, all of these science and engineering fields are high spatial fields, and by improving a student's spatial skills, we then improve their success in that course. We also looked at overall success. So this graph shows the graduation rates for students who come to the university and they initially have good spatial skills. So you can see that for the women, they're graduating from engineering at about a 70% chance, and the men at about a 60% chance. So this shows you, I think, the importance of spatial skills for success in engineering. But what happens to the people who come with poor spatial skills? We see a big drop-off for the women, right? So instead of 70% of them graduating, we only have now less than 50%. It's about 47%. The men drop off as well, not by as much. The drop-off is really dramatic for the women. And personally for me, if we're trying to get more women to go into engineering, we should try really hard to keep the ones there who say they want to do it. So what happens now if we take students who have initially weak spatial skills and we give them just this little bit of training? Well, now the women are graduating not only at a higher rate than the people who have poor spatial skills, but now they're graduating at a higher rate than the people who started out with good spatial skills. So the women went up to about 77% compared to 70% graduation. The men, basically, they went back up to where they had been if you have good spatial skills, but that's good too. We need more men in engineering as well as women. I've always said that I want to make the need for my course to go away. What that means is I want every child to come to the university with well-developed spatial skills so that they can be successful in the science and engineering and math fields. So what can you all do? I assume you have children, grandchildren, nieces, nephews, friends, somebody in your life that you would want to encourage to go into engineering or science or math. What can you do to help them develop their spatial skills? Well, the first thing is Legos. And I don't own stock in Legos, so I'm not profiting from this. But really, if you have a picture of something that you're supposed to be building and you give your child some Lego bricks and they can build it, that's the first step on an engineering or science path. Now, unfortunately, many of the Lego kits don't always appeal to the young girls. So there's a new product in town, and again, I don't own stock in this, but it's called Goldie Blocks. And it's supposed to be kind of a Legos, but more aimed at the kinds of things that young girls like to do. So Legos, Goldie Blocks, what else can you do? Maps, not GPS. So when you take that family vacation, instead of relying just on the GPS, give your child a map and say, help me plan the route. And have them learn about the relationship between what is on that piece of paper and the space around them. There was a study that showed that because we're using GPS right now, we're actually losing some of our spatial skills as a society. IKEA. Again, I don't own stock in any of these companies. IKEA. We've all purchased furniture. It comes in a box, and we take out all the parts, and there's a picture, and we have to put it together. A bookshelf, a chair, a footstool, a table. Have your daughter help you put that together. If she can figure out how the parts fit together, where those screws go in those holes, she'll be better off, and she'll probably be developing her spatial skills as a result. Sketch real-life objects. Don't just doodle. Don't just draw funny things. Sketch real-life things. And then turn them over in a different vantage point and have your daughter sketch it from that new vantage point. So sketching is one of the things we found very important for developing spatial skills. And finally, 3D computer games. Now, I know that you probably as a parent don't want to tell your child, no dessert for you unless you do 20 minutes on your computer game tonight, because that doesn't sound like a good parenting technique. But 3D computer games have been shown to help develop 3D spatial skills. Now, 2D computer games are not helpful at all, so you don't get credit for doing Angry Birds. But if you can get your child to do 3D computer games, that's great and will help him or her develop their spatial skills. Same thing with Legos, though. There's not a lot of games that appeal to young women, so you really have to look to try to find the ones that will appeal to the young women in your life. And that's really all I had to say. I want to thank you for your kind attention.